All right, dude, we are live. What's up, guys? This is Dem Keys, and give me a second here because I forgot something. There we go. All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning about proto-buffers and, well, proto-buffer, I think. ProtoBuf. Let's say ProtoBuf. I don't remember if there's an S in buffers there, but yeah, we're going to be learning about ProtoBuf, and actually there is, I believe there is. Hold on. This is something incredibly stupid for me to focus on. Protocol buffers. Yeah, we're going to be learning about protocol buffers and flat buffers. More we're going to be learning more about protocol buffers because yesterday I decided to do some research. I believe it was off stream, but I think the curiosity kind of arised on stream where I had seen flat buffers being mentioned. So I was like, let me Google what this is. I don't remember if I actually, got the information on stream or not, but eventually I did get the information, whether it was on stream or off stream. This is essentially a serialization format, or, well, it's a set of tools that allow you to describe how your data can be converted, can be serialized and deserialized to and from a certain format. Now, the interesting thing here is, and I was like so glad that I actually looked into this, because it turns out that this is something that I had been searching for in some of my older projects. To give you an example, in in my earlier version, or, well, the current version of my VTuber app, I had like multiple components. One of them was the VTuber app itself. Another one was the Twitch middleware app. Then there was what was it? What was it? The Stream Deck, the virtual Stream Deck app. Now, in order to get all of these apps to communicate together, I needed a fixed protocol. And so I had to come up with my own protocol for that purpose, because there was certain data that needed to be common amongst all of them. I basically had to come up with my own protocol spec. It wasn't the best, but it got the job done. Initially, I was doing it using JSON, and then because I also needed real time data in some cases, so JSON became just a huge hassle. So I wrapped that protocol into, or I wrapped that format into a packed version of that format. So I sort of created a container to hold that format, and the entire thing, I basically made it binary. So of course I would have to come up with the way to convert all of that data into bytes, right? So what I did was I came up with a message packed format, and within that format, all of the data that would be actually, okay, I should mention this. There was the message. Hold on, I can actually open up the, just a second. I can open it up here so I can show you, because at this point I myself might be getting some details wrong about it. Fortunately, I did put up the spec on my GitHub, so I can take a look at that. And this is a perfect example of something that I could have used, or this is a perfect example of a situation where I could have benefited from either protocol buffers or flat buffers. Because, okay, these are two separate protocols. These are two separate systems that solve different problems. They solve, okay, they solve different problems, but they do essentially the same thing. The whole idea is you define your format in using some kind of schema, and the schema's language will be determined by which tool you're using, because ProtoBuf uses its own version, and, well, it uses its own syntax, and FlatBuffers uses its own syntax, at least from what I've seen. Okay, so you define your entire schema. You define what the data is supposed to be within that schema, and then you run a tool that's gonna that's gonna generate code containing getter and setter functions that will allow you to, in the case of set, it'll allow you to serialize your data into a binary format, and in the case of get, it'll allow you to deserialize the data from a binary format. And you don't have to write any of these getter and setter functions. That's the amazing thing. That's the whole idea behind this code generation thing, is that you would then be able to use, depending on whether you're using ProtoBuf or FlatBuffers, you would then be able to use these respective libraries along with the getter and setter functions that have been set up. So the 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 compiler for these tools, for each of these libraries, it's gonna generate the code for you. So for example, if you're trying to do it in Rust, it'll generate the Rust code for you, which will be presented in the form of a module of some sort, or maybe multiple modules, and you can then just include that code into your project, and you're good to go. You have your serialization and deserialization methods right there. And the great thing here is that, again, you don't have to write any of this code. You can wait. I just realized I'm on BRB. Let me show you what I was trying to show. Okay, let's go to repos. And in here, hold on just a second. Yeah, there it is. Okay. Dude, I was supposed to start the stream like 45 minutes earlier than I actually did, but then I got kind of I got kind of busy because I was trying to install the protocol buffer compiler, or the ProtoBuf compiler. And yeah, I had some issues because on one of my machines it installed fine, and I didn't realize that it installed fine. Um, I thought that's where the issue was, but the issue was actually on another machine. On another machine, I already had the proto compiler, proto C. I already had that installed through Anaconda, and I didn't know it was already installed, so I tried to install it using apt instead, and so it installed and was using some different version and stuff like that. So there was a whole confusion there. And then eventually I decided to just get the binaries from the repo, and like unpack that, and then set my environment variable to point towards that directory. But I still haven't gotten the system to actually see that version. For some reason, it still seems to be seeing the Anaconda version. So now I have to try and uninstall Proto-C from Anaconda, and I haven't managed to do that yet. Fortunately, the machine that I'm the machine that these two tmux instances that you're seeing on screen right now, the machine that these two instances are running on, I managed to install it properly on that. It's just on the other machine that I haven't managed to install it properly. I'm going to be honest here. So I had installed Anaconda on this on the other machine ages ago, and this was like a long time ago when I barely knew what I was doing in terms of package management. I'd mainly installed it for Python because I was finding the whole environment thing. It just, I didn't manage to wrap my head around the concept of environments. And so I was a little confused about what was going on. And in my confusion, apparently the research that I did told me that, hey, installing Anaconda is a much better approach because things are so much better within this environment. And to be fair, that is true to a certain extent. That is true because Anaconda does have its benefits, but I have seen how it can interfere with stuff as well. Like in this case right now, when I try to install this thing that is installed like globally in Anaconda, now it's kind of like interfering, and it's not letting me use the version that I want to use, the version that is not installed by Anaconda. Anyways, it is what it is. I need to fix that mess. It's more or less about like setting the environment variable and getting getting the path of the one that I want to use to be seen first before conda. I need to make sure that that path is seen first instead of conda. Okay. Um, where was I? I was also having a conversation with Gemini about this. Like you can see, Gemini was giving me some information here, and I might actually go with uh, this suggestion as well, which is creating an alias. So that way, when I type protoc in or proto-C, it's protoc sounds so much more cooler. But anyways, when I type proto-C in the shell, then or in the terminal, then it'll directly point to that binary. That seems like a much more straightforward solution. It can become a bit confusing later on if I delete the folder and like replace it with a newer version, and then all of a sudden the link is just broken because the alias is like pointing to nothing. Which, to be fair, I mean, that could be the case with like if I change the path, the environment, if I change the path, if I modify the path environment variable, it's an environment variable called path. If I change that path, I could still run into the same issue because that could also be pointing to something that doesn't exist. But yeah, okay. Um, so protocol buffers and flat buffers. I've been trying to like I did a bunch of research yesterday on this. I've been doing research today before stream on this. And I've been trying to decide which one I wanted to go with because I really liked the way that that flat buffers does things. So like flat buffers has this the way that flat buffers works is that it allows you to read from the massive blob of data. So the idea basically is that your you define a schema in both protobuf and flat buffers. You'll define a schema that dictates what your data is supposed to be. You're essentially defining the layout of your data, and then you're going to use the compilers for these respective tools and generate the code for your respective language, whichever language you're looking to generate the code for. You'll generate the code. This code contains the getter and setter functions, and then you can use these getter functions, or okay, I should start with setter. You can then use these setter functions to serialize your data from your program into a binary blob, and you can use the getter functions to deserialize the data from the binary blob. The interesting thing with flat buffers is the way that the system is designed, you can read from anywhere in between the binary blob. So it could apparently even be on a file, and you don't have to load that entire binary blob. You can just read at specific offsets. You don't have to do that. You have to tell flat buffers that, hey, I want to read from this blob and I want to get so and so thing. And because of the code that's been generated for you, it knows how to do that reading. So one of the advantages here is that with protobuf, apparently you would need to read the entire binary blob into memory first, and then you can read anything from it. But with flat buffers, you can directly read it from disk, so you don't even need to load the entire blob at once. You can like load a small bit of it or load specific sections of it, and each of these techniques, each of these systems, they have their, or let's say each of these protocols, they have their pros and cons. They have situations where they would be useful and situations where they might not be the best. I was just trying to decide which one I wanted to go with because I'd seen flat buffers being used in what was it called? Solar XR something. Solar XR protocol. It's a protocol being used in Slime VR. So I'd seen it. I'd first seen it there, and so what I did is I cloned the. Oh, I can't show it to you guys here because I didn't clone it on this machine. I cloned it on another machine. Well, anyways, I cloned it. Oh, you know what I could do? I could hold on. I'm not going to read through the. Nah, that's that. Even exporting it is going to take some time. But yeah, I cloned the repo and then I CD'd into that repo and I started up Gemini there and I said, okay, analyze this entire repo and explain to me what's going on here because I've seen um, I've seen words you know what? Okay, hold on. This was great because like I walked into this thing completely clueless of what's going on, and now I have a pretty decent idea of how both of these systems work, and I'm definitely not going to be looking back on this because like well no, I should say I'm not going to be turning my back on this. I'm definitely gonna look further into this because I can use this. I can use this for my own purposes. Like there have been situations where I wanted. In fact, dude, I can even use this for the Stream AI voice app that I was planning on working on. Because like even there, we're gonna have a sort of format that's gonna um that we're gonna have like a what was I calling it? TTS packet, I guess, or TTS message, TTS packet. We're going to have a TTS packet message, which is going to have a bunch of information laid out linearly in it. So we could benefit from using this protocol because this way I won't have to implement the serialization and deserialization logic, whereas previously I was definitely going to have to, unless I used something like message pack, which, by the way, at this point, maybe no. You know what? I just remembered. I was planning on using message pack as well. I was gonna look into message pack, though. Hold on. This reminds me that maybe I should add to the list. Was it here? Yeah, okay, give me a second. I need to open this thing up. Yahtzee. Okay, it should be under documents, I believe. Mind map and streaming mind map. All right. Does it accept? Yes, it does. Okay. So HMM, open that up and we are good to go. Oh, just a minute. Let me also open up my stream manager so I can see the chat. Okay, so yeah, things to focus on. All right, this is still on. This is still all very much on. Finish learning Gemini Rust. We need to, yep, we need to finish that. Current focus. Okay, okay. Temp. Things to look into. Redis, message pack, audio encoding. Okay, here I need to, wait, do I need, spec. There was things to look into. There was message pack. Okay, here, let me add ProtoBuf and what was it? FlatBuffers. Though I think I'm going to be using ProtoBuf. I think I might just use ProtoBuf. But yeah, what was I doing? What was I saying? Oh, I was gonna export something here so I could show it to you guys. Because it's a whole conversation that I had with Gemini. Um, and then Gemini explained the entire thing to me. It took me a little bit to understand. You know what? Maybe I might not, because like the explanation doesn't really matter. I can tell you the prompt, and then I can tell you what I learned from the response. So my prompt was this: Hey, so I've cloned the Solar XR protocol repo in this directory. Can you analyze this repo and tell what it's all about? More specifically, I'm interested in the Rust side of it, but I'm also curious about how it's implemented in the other languages because I'm seeing words like schema and generated being mentioned either in files or directory names. I feel like this is a situation where a protocol is being described in a common format and then somehow code is being generated for other languages. Okay, then Gemini's response was this after analyzing the repo. Gemini said this: You are spot on with your intuition. This repo, Solar XR protocol, defines a communication protocol for virtual reality, VR, full body tracking using FlatBuffers. Here's a breakdown of how it works, addressing your questions. Schema driven code generation. Your observation is correct. The project follows a schema driven development approach. The schema, the schema what? No, there's two things. Okay, so first of all, the schema. The schema directory contains the protocol definition files with um, all.fbs. I think FBS is the flat buffers like format, the extension for the schema file being the main file. These files define the structure of the data, like messages, data types, etc., that can be sent and received. FlatBuffers is a cross-platform serialization library, which is why it's a good choice for this kind of multi-language project. Then you have code generation. The generate flatbuffer .sh script is the key. It uses the flatbuffer compiler, flatc, to read the FBS schema files and automatically generate the necessary data structures and serialization slash deserialization logic for each target language. Dude, I just realized that I did not read any of this. These two specific things I did not read. I think I jumped down to the Rust implementation of it. Yeah, I think I jumped down to the Rust implementation of it. Or maybe I no, maybe I read it and maybe I was just sleepy at the time, so I didn't really grasp it all that much. Because I do remember reading it to a certain extent, but I was like, I don't know. Okay. Um, But yeah, it mentions there's the serialization and deserialization logic for each target language like C++, Java, Kotlin, Rust, and TypeScript. This generated code, well, these are the languages in that specific repo, but this compiler does support more languages. So does Proto-C. Okay, this generated code is placed in the generated directories you've seen. This approach ensures that all language implementations are consistent with the protocol definition. If the protocol needs to change, developers only need to update the schema and rerun the generation script. So this is what I was talking about, right? You save, or this saves you the headache of having to re-implement the code in all of the different programs, or if you have like a standard library, if you have like one library that has to be, you know, um, has to be referenced in every single project, you would then have to edit that code as well. But in this case, you just have to edit the schema, and then the compiler can generate the code for you, and you just have to replace the code. And actually, you don't even have to replace it. I think you would just need to replace the files that that are being referenced for the code. So for example, in the case of Rust, the modules that are being generated, you would just need to replace those files so that whatever is in your main code, it's pointing towards the right files now. And that is, dude, I wish I had learned about this. This is, dude, one of those situations where I'm glad that I'm constantly exploring different projects and learning about because dude, I come across so many of these things that I wouldn't have otherwise come across if I were just sticking to one field and just doing everything within that field or within that one project and limiting my scope. There are so many things that I wouldn't have learned if I wasn't constantly exploring things. Like, holy shit, dude. Now that I know about ProtoBuf and FlatBuffers, I'm going to be using it a lot. For the time being, it kind of seems like ProtoBuf is the way to go. But in situations where I'm very much memory constrained, I might look into flat buffers. Or if I'm in situations where I'm working with like limited hardware, a lot of times it's a memory thing. Especially if you're working on like embedded systems, it'll be a memory thing. You might not be able to load an entire blob into memory. Fortunately, most of the time I'm doing stuff with uh, with computers and not always with microcontrollers. But in situations where I am doing stuff with microcontrollers, I might need to look into something like this. Though it is worth noting that I did try to do research on no STD support for flat buffers, and it in some older discussions that came up on Google, so far people are kind of iffy about it. Someone said that they did manage to do it, but not on ESP32. They were testing it out on another microcontroller, which is STM something something. I'm gonna have to do some more research to see like to what extent it's possible. Though, okay, it's also worth noting that um, this this format, like this whole system, it's not just useful um, for implementing communication in a performance-friendly way and in an efficient way. This can also be used for writing data to the disk. Like if you're trying to save data, you can use this serialization format to do that, because there are often situations where you would anyways need to define some sort of format in order to store a whole bunch of data into a file. Like if it's a game, for example, there's going to be a bunch of variables that you have to store, right? There's going to be a structure, like maybe there's, I don't know, a set number of enemies, or there's a player and the player has a bunch of stats, and the entire data, like it has certain structure, certain hierarchy and stuff like that. So in order to preserve that structure, preserve that hierarchy, you would have to define your own format to store this data in. Not only that, you would again also have to define serialization and deserialization methods for that format, unless you want to go with something simpler like JSON. But like, to be fair, even with JSON, you would need to define at the very least some kind of object or class or something that defines the structure. And then JSON, depending on the language, JSON manages to serialize and deserialize, right? Instead, you could use this schema method, because if you anyways have to define stuff, you might as well just use this. And if this is also lightweight, if it's not that heavy, um, then you might as well just use one of these. And I think from now on, I'm gonna do just that. For now, I want to learn ProtoBuf. At some point later, we might look into flat buffers as well. I am trying to. So far, I have installed ProtoBuf. Where was it? Here? Yeah. So far, I've installed ProtoBuf. We could look into. Oh, wait. I was gonna show you guys the spec. So in the spec, this is the protocol that I'd made. You have the raw message protocol, which is this. The format was simple. It's just a magic number to say that, yeah, this is a raw message. The magic number is basically for actually it's receiving a raw message. The magic number, I believe, was for what type of message it is. So it could be a DVT-MP message, it could be a body pose message, it could be DVT-MP message packed message, which was it was a packed version of the DVT-MP message. So the DVT-MP message was, I think it was more JSON based, and that wasn't really working out because all of this was running in C sharp, and if you do string stuff, then you run into garbage collection issues. So I made the packed format. So this is what I was talking about, like with the container kind of thing. You have the raw message protocol, which is essentially a container for the actual message. I don't remember what MDL was. It says MDL chat message. Um, MDL, was it middleware layer? Could be middleware layer. I think so. Yeah, because it says chat message, right? So yeah, it could be middleware layer. I think I had written this for the Twitch middleware app that I had created, just so that that app and the main VTuber app could communicate together. But yeah. So this is a good example. You have the raw message protocol, which wraps the actual message, and then you have the actual message. Each one of them would be like defined in their own way. Generally, most of the time I was using message packed. Message packed was more or less a binary format. I think body pose was also binary. I believe I had to make it binary just so, because like body pose was sending proper real time data, and I'm not sure if I did a good job of implementing the thing, because there it did introduce a bit of lag over time, which I never really fixed that issue. Once I re-implement this on the Rust side, I'm curious to see how good or bad it performs. Though to be fair, on the Rust side, I'm gonna be doing a bunch of multi-threading, so it might just perform a lot better. Who knows? Um, yeah, dude. Let's go to this. So we can read this for now. Give me a second. Okay, let's do it. Let's do it this way. So, protocol buffers. Protocol buffers are language neutral, platform neutral, extensible mechanisms for serializing structured data. What are protocol buffers? Protocol buffers are Google's language neutral, platform neutral, again? Okay, extensible mechanism for serializing structured data. Think XML, but smaller, faster, and simpler. You define how you want your data to be structured once, then you use special generated source code to easily write and read your structured data to and from a variety of data streams and using a variety of languages. Pick your favorite language. Protocol buffers support generated code in C++, C Sharp, Dart, Go, Java, Kotlin, Objective-C. I haven't heard that name in a. Oh, that was Apple's thing, right? Objective-C. Yeah, that's probably why I haven't heard that name in a while. Okay, Objective-C, Python, and Ruby. They haven't mentioned. Okay, with Proto 3, you can also work with PHP. So they haven't mentioned Rust, but there is Rust support from what I understand. Because if you go down here, Rust is mentioned. Yeah, Rust is mentioned. So we can take a look at we can take a look at that. All right, example implementation. Right, so we define the message. This is going to be our container. In the case of Rust, it would be a struct. I actually want to use this in both Python and Rust. Because like I wanna see what it would look like on both ends. Um, yeah, yeah. But I definitely want to use this on the Rust side a lot because uh, especially with the Stream AI voice app, I feel like I'm going to be able to benefit from this a lot. Hello, hello, Icarus. Welcome to the stream and thank you for the lurk. I hope you're doing well. We are currently learning about protocol buffers, which is it's basically a more automated way to create serialization and deserialization features and functionality within your programs. Also, yesterday when I was reading this, I think I found this out thanks to Gemini. I was assuming that these are values, but these are not values. These are IDs for these different variables. Okay, this is a proto definition. Um, all right, then here's the Java implementation of using a generated class to persist data. File output, okay, okay. So it's doing what I was talking about before, where you're like saving data to a file. So it's not only about communication. You can very well use it for serializing data to store and then deserializing data that has been stored. Another thing that I was looking into, which I might be able to copy that right now because I was having this conversation with Gemini early on because I was curious about um just a second. I want to get the right place to copy it from. I think it was this. Yeah, it was this conversation. So I was discussing with Gemini about how, if at all, compression is applied to this, because especially with something like flat buffers, if you are just able to read from anywhere in the blob, I don't think compression is being applied to the entire blob, right? Because that would then defeat the purpose of being able to read from anywhere in between the blob. You would have to decompress the the entire blob, and then you could read from anywhere in between it, which again defeats the purpose because you're kind of loading the entire blob, right? So it turns out that's not what happens. There is a certain kind of compression being used, but in this case, it's not exactly compression; it's encoding. So I'm guessing it's just using clever ways to pack the information, which is exactly like what I was looking for. Let me export this so I can then bring the file over. Okay, so what was it? Chat, share, Gemini explains. I'm just gonna have like the lower part of the conversation, right? So, uh, ProtoBuf um, specs, let's say, .md. Okay, so you export that, and then here I can go into Scratch stuff, and do we have the file? Gemini explains protobuf specs. Okay, so we're going to send that over to the other machine. Um, Gemini explains this. Okay, And then we need to put in this path, scratch stuff, empty directory, and okay. All right. Okay. We should have the file here. Now, do I have anything open here where I can, why do I have Python open here? That's a bit concerning. Hold on. Oh, that's why I had it open. Okay. It shows it's showing frogmouth as that as Python. Okay. Um right. So here I can I need to keep this open. I can't get rid of this. Um Maybe I could just close this one. Wait, what is this for again? Yeah, this was in this was a yeah, no. I'm gonna keep this. I'm gonna keep this open because this is actually something interesting that is like it goes into like syntactic sugar that Rust provides for very specific things, right? You can like that syntactic sugar makes it so you can write things in a certain way, um, and you wouldn't have to do it in a more verbose way otherwise. As in, let me say that again. It The syntactic sugar makes it so you don't have to do things in a more verbose way. You can do it in you can do it using the syntactic sugar. Syntactic sugar. You could do it in the more verbose way if you wanted to, but just using the syntactic sugar is more than enough. However, I do want to learn what that syntactic sugar usually expands to, because that helps my understanding a little bit. And I only learned about like various types of syntactic sugar because I started doing research on what different things meant in Rust, like when you're trying to when you're trying to borrow a field from a struct, are you borrowing the struct and then borrowing the field, or are you just borrowing the field? And in that case, what's happening to the struct? And then also there was something that I was looking into, which eventually brought up the concept of operator precedence, which is kind of like arithmetic precedence, but in this case, it also includes uh, dereferencing operators and borrowing operators and stuff like that. Okay. Moving on. I do need to continue this. Um, yeah. I do need to continue this. We'll continue this, but for now, oh, actually, I just remembered something. I exported the entire thing. I exported the entire thing. I was supposed to delete some stuff from it, which isn't really a huge issue, really, but like, hey, so I just learned of the existence of flat buffers. In the past, I've heard of protocol buffers and so forth. Oh, this is a different conversation. So in this conversation, the way this conversation started was that I told Gemini that I've heard of, I recently learned about flat buffers and protobuf or protocol buffers, and I've used JSON in the past, so I know I've heard about JSON, I've learned about JSON in the past. Of the three, I literally only know about JSON. And so I wanted Gemini to explain the other two to me, and Gemini did. Um, yeah, I don't think I have to delete too much from this. We can just, yeah, it's fine. whatever. So we'd open this up with Frogmouth. I can transition back. Open this up with Frogmouth. All right, so here I was asking the question, and then Gemini gave a lot of very useful information and taught me about ProtoBuf and about FlatBuffers. It taught me about FlatBuffers and a lot more in a different conversation than this one, but I did learn a lot about FlatBuffers here as well. Okay. Um, Couple of things. Oh yeah, this was I believe this was where I had asked. I learned about flat buffers and so around the same time, but in my research I've gone slightly further with flat buffers. I understand that they both have their pros and cons, but if I have to choose between, if I have to choose one, I'm wondering which one I should go with. Currently, I don't have an incredibly specialized purpose. In the future, if something does come up and the other one turns out to be useful, I can learn it, but I'm just wondering. And then I got the response, but I had forgotten to add another much longer question. So I re-asked the entire thing. I said, yeah, sorry, I have to ask again because I missed a question. Okay, a couple of things. Right. So the fourth question in this prompt was, so I understand that both of them turn data into binary data. What I'm wondering is, what are some characteristics of that data? I doubt I need to concern myself with all the specifics of the design of that binary data, but something that really piqued my interest was the size of the data. More importantly, how small the data, what? I wrote how small the data apparently because. I think I meant to say apparently is. And this is apparently without any compression either. Though I don't know if it's applying its own compression, but I'd imagine that if you're just able to read values out of the blob using getter functions like in flat buffers, there's no compression being applied to the whole blob. Though I don't know if there is some kind of packing slash compression being applied to individual values. So first, Gemini answered that fourth question because it had answered all of the other questions up here. So it gave like concise answers for the other three and gave like a nice long answer for the fourth question. And then I was like, okay, I don't want to read the stuff on top. So you don't need to be concise with the other three. You can just give a decent amount of information, and then it gave even more information, which I'm gonna look into. Well, I'm gonna read that. Um, right. So first, we're going to talk about the compression, and this is where I found out that yeah, it uses encoding. You've asked a perfect follow-up question. Your intuition is spot on. There's no traditional compression like zip or gzip on the whole blob because that would make direct field access impossible. The magic behind the small size is all in the encoding. They achieved their small size by stripping away everything a human needs to read. What? Oh yeah, okay. This is a blob, so it's not human readable. Okay, by stripping away everything a human needs to read data and storing the information in a way that is maximally efficient for a machine to read. Let's break down the characteristics of that binary data and how it gets so small. Imagine you have this. Imagine you have this simple piece of data in JSON. All right. Um, this might be around 45 bytes as a text string. This is how protocol buffers and flat buffers would encode this information. Oh, here is how protocol buffers and flat buffers would encode this information much more efficiently. They throw away text keys for field numbers. This is the single biggest space saver. The string is active, takes up 9 characters. Okay. This key is repeated for every single object. You know what? I just realized this. Yeah, okay. A bunch of the information can be abstracted away. Not abstracted, but like, well, abstracted away. What's the right word to use there? Um, Not optimized away. It's hidden away, but it's not really hidden because what's happening is we are creating these specialized getter setter functions which know exactly where to read the data from. That's why you don't need these specific keys because you have the functions that know how to get this information, right? Anyways, let's carry on reading here. So this is the single biggest space saver. The string is active, takes up 9 characters. The key is repeated for every single object. In a .proto schema, you'd define it like this. Okay. Oh, is it like creating one? So because they mentioned the repetition of the key, it's also possible that they are substituting where the key is supposed to be with an index of some sort. So they'll create a table with all of these names, all of these key names, and then in the actual data, it's just integers um, that are pointing to a specific index in that table, and that's how you know that okay, this is the key for this value. In the binary data, the key is active is replaced by the number 3. So instead of storing the text, the binary data just has a tiny marker that says field number 3 is coming up next. Okay, they use efficient integer encoding. So all of this, I don't really need to be concerning myself with this, but this is mainly for my curiosity, so I can understand this protocol better, both of these protocols better, because I'm assuming in both of them it's done in a similar way. Also, I believe both of these are made by teams at Google. Okay, in JSON, the number 2 is stored as a character, which takes 1 byte. The number 200 is 3 characters, which is 3 bytes. The number so and so is 7 characters, 7 bytes. Yeah, okay. Protocol buffers uses a special technique called variable width integers or variants. The idea is simple: use fewer bytes for smaller numbers. Okay. Most of the integers we use in programming are small, so instead of reserving a full 4 or 8 bytes for every number, ProtoBuf uses the space it absolutely needs. Only uses the space it absolutely needs. This is a huge saving. Okay, they use pure binary for everything else. So booleans in JSON, true is 4 characters and so on. Yeah, that can be 0, 1, a single bit. Yeah. Strings. The string Bob isn't stored with quotes. It's encoded by first storing its length as a var int, followed by the raw UTF-8 bytes for Bob. No syntax. There's no curly brackets or colons or commas or white spaces. All of that is stripped out. The structure is defined by the field numbers and type information encoded in the stream. Putting it all together, the binary data for our user object would look something conceptually like this. Okay, this would result in a payload that is likely only 8 to 10 bytes instead of 45 bytes used by JSON. This is an 80% reduction without any compression at all. Now to readdress your other questions concisely. Okay, so my other questions here, before I go into like the, more expanded versions of those questions, or expanded versions of the responses to those questions. Um, so I'd asked here if the same rings true for flat buffers as well. I can't remember exactly what that was. I think, okay, choose which one to learn first. Okay. Oh, so here it was just giving like um, a summary of how this. Hold on. This is what it was. Okay, now I got it. I was having trouble remembering. I was about to say it gives a summary of like um, the overall speed and size kind of benefits, but no, that's not true. Here I was asking the question about what else can, other than, okay, so initially so far the conversation was about like, okay, we can use it for communication, it can be really useful for this communication, that communication, great. Sending data from one place to another, awesome, right? Then I was like, okay, what other situations can it be used in? Because I had a doubt that maybe it can also be used for writing to a file, like just saving the data and loading the data instead of sending and receiving data. So I asked the question, wait, so I've only been thinking about protobuf and flat buffers use cases in terms of communication between apps, services, etc. I feel like there's probably other situations where they could definitely be useful. And then Gemini told me that yeah, you can use it for situations where you're writing data to a file and reading data from a file. And so then I'd asked, the same rings true for flat buffers as well. And that's, yeah, that's right. For flat buffers also, it rings true. In fact, with flat buffers, you have the added advantage that it doesn't, apparently, I haven't tested it out yet, but based on what Gemini is telling me, with flat buffers, you have the advantage that it doesn't load the entire blob at once. You can just point it to the blob and tell it that I want so and so thing, and it'll pick out that specific bit of data and read it for you. So you're not loading the entire thing into memory, which has its own benefits, definitely. Oh, yeah. Okay. So the next question was, is there really that much of a difference between the speed and size between flat buffers and proto buffers or protocol buffers? Right. So now we go to the expanded versions of these answers. Okay. So the response here, actually, okay, this was where I got the idea of like, okay, right. So you guys need to like be able to imagine this. So I'm gonna read it. So the same rings true for flat buffers as well regarding the data at rest. I love that Gemini actually pointed this out because I myself was having trouble remembering what it was in reference to, but somehow Gemini remembered it despite me retyping the question. That's interesting. Okay. Yes, absolutely. And in some data at rest scenarios, flat buffers provides advantages that are even more dramatic than with protobuf. While both are excellent for storing data efficiently in files, their strengths apply differently depending on how you intend to read that data back. Protobuf for data at rest. Imagine you save your application's state as a protobuf file. When your application starts, it performs these steps. It opens the file, reads the entire file into a byte buffer in RAM, and then it calls so-and-so function to deserialize the data. This creates a complete new set of objects on the heap representing your state. The original buffer can now be discarded. Okay. This is a fantastic approach when you need to work with the entire data set. It's much faster and more memory efficient than parsing a giant JSON file. Now, flat buffers. Now consider a different scenario. You have a massive file like a 2 GB game asset file. a dictionary or a machine learning data set. Loading all of that into memory and parsing it would be would be slow and might even crash your application on a memory constrained device. This is where FlatBuffers shines, often by using a technique called memory mapping, mmap on Linux/Mac OS, or similar features on Windows. Here's the workflow. You tell the operating system to map the file on disk directly into your application's virtual address space. The OS doesn't actually load the 2 GB file into RAM. It just creates a pointer that pretends, I'd heard about mmap. I never actually used it myself. And I need to see if there's a way to do this in, actually, yeah, let me look this up. I'm curious about if there's a way to do this in Rust and in Python as well, because I've legit never done this. Anytime I need to read a file, I'm reading the entire file into memory, so that I can then iterate over the data. Rust mmap. Okay, mmap in memmap. What? Okay, memory mapped files in Rust allow direct access. I forgot about this as well. Memory mapped files. I completely forgot about this because this was one way of doing IPC to a certain extent. To a certain extent. This was one way of doing IPC. Or was that something else? There was like a shared memory location kind of thing that you could do, where you could share like a block of memory between multiple processes, and they can like each access it whenever they want. Um, okay. Yeah, I want to see if memory mapping is a thing in Rust, and like what is the Rust equivalent if it isn't a thing in Rust already. Um, Hold on. I'm just loading up this page. I'm developing a library. I'm reading out this thing from Reddit. I'm developing a library and a CLI tool to parse a certain dictionary format. The format of a dictionary app called Monaca Kido. Okay. Every time the CLI is used to look up a single word in a dictionary, the dictionary indexes are loaded in memory. This is easily tens of megabytes per lookup. I'm using a 10,000 4K. What? I'm using 10,000 4K page loads as my working rule of thumb. Okay. Of this, only around 15 pages are actually needed for the index for the index lookup. And even in this, okay, I'm guessing the point is that it's a massive file that they have to read, and so they wanna find a easier way to read the file. The mmap problem has always frustrated me because people overanalyze what it actually means for spurious modifications to be considered undefined. The Rust compiler forbids programs from modifying immutable data that does not go through unsafe cell. A Rust program that does this is ill-formed, and the compiler gets to punish it. Okay, all right. Your program doesn't do this. It is well-formed and will compile correctly. The foreign process may modify problem is. Wait, so this person did manage to get into mmap or memmap, and immutable memory map. Oh, you know what? Wait a minute. Wait a minute. There's something that I need to, like, there's a differentiation to be made here. In that person's project, are they writing to or just reading from? I didn't look at that because okay, they said I'm developing a library and a CLI tool to parse a certain dictionary format. Every time the CLI tool is used to look up a single word in a dictionary, dictionary indexes are loaded in the memory. This is easily tens of megabytes per so and so. Okay, all right. This is not a problem for a single invocation or multiple lookups that reuse the same loaded indexes, but in some scenarios, the CLI tool is invoked repeatedly in a loop and the indexes are loaded again and again. This led me to consider using mmap to get the pages to load on demand. I haven't tested it yet, but natively I think using mmap, maybe I could open this up here so like you guys can also read the thing. Give me a second. Rust mmap. No, no, not mmp. Mmap. Okay, so there's mmap in, well, mmap in memmap. I need to look into what memmap is exactly. Also, let me look at the Gemini definition of this. So there is a memmap too. Give me a second here. Let me open this up. Memory mapped files in Rust. Why are memory mapped files unsafe? Apparently, Cloudflare has made memmap sync or mmap sync, a Rust library for concurrent data something something. I'm going to open that up as well. Is there no safe way to use mmap in Rust? Okay, all right. So I can transition back. Actually, real quick, there's one more thing that I have to do. Right. Okay. We should be good, I think. I think so. Yeah, yeah, I think we're good. So let me transition back here. Actually, let me take a sip of my energy drink and let me drink some water, and then I will come back to this and we're going to read and see how to go about, you know, doing this whole thing. Because I feel like this information can benefit me in other situations as well. Because like I mentioned before, I've never actually practically used memmap. So I feel like having situations or knowing how to read from a file without actually loading the entire file, that can be really helpful. So yeah, give me a second. Let me hydrate. Okay, so now first things first, let's so this is a cross-platform Rust API for memory mapped buffers. Let's take a look at the repo. Wait, this is from like 7 years ago. The last commit to this was 7 years ago. Not that that's a problem, but that has me wondering if there are better ways to do exactly this in Rust now. Let's see, because there are questions from like 3 years ago, questions from 4 years ago, from 2022 as well. Um, there's this Rust library for concurrent data access using memory mapped files, zero copy deserialization. And oh, is this what's being used now? Maybe. mmap sync is a Rust crate designed to manage high performance concurrent data access between a single writer process and multiple reader processes, leveraging the benefits of memory mapped files, weight free synchronization, and zero copy deserialization. We are using mmap sync for large scale machine learning. Detail in our blog post, so and so. Scalable machine learning at Cloudflare. I should read this. I should read this at some point. But yeah, I'm gonna keep this open. Um, they mentioned concurrent. I'm wondering if this is using like Tokyo or some other kind of async runtime in order to achieve what it's achieving. Let's take a look at the toml file, or the cargo toml file. Um, I'm not seeing anything that immediately tells me. Yeah, I'm not sure. I'm gonna have to look into this. Um, well, I'm gonna have to actually see examples of this in order to understand what they're talking about. Oh, you know what? Okay, let's take a look at the examples. Though, I mean, well, okay. Let's take a look at the examples. Yeah, there's no like async stuff going on here. So I wonder what they meant by concurrent. Maybe they meant something else and I just understood something else. Possibly, yeah. I think I just understood something else. Okay, let's read. So this is from 2022. I think the main question here is whether a race with another process in an M-mapped region is UB or not. What does UB mean here? If it is, I don't think you can safely use mmap at all. If your OS will guarantee that map private will always fault in a private copy of each page you access and never evict these pages to be reread later, there might be a way to do it. POSIX allows POSIX allows but does not guarantee this behavior. So your code will be tied to a specific OS version rather than generic Linux/Unix. Okay. Now this seems to be going a little too low level. This is not what I'm looking for. This is definitely not what I'm looking for. I'm here. I need to go here. We can start from here. Okay. How to use um yeah, okay, this was the one that I was reading earlier, like on a different machine. Let me zoom in. Okay. What's undefined about this is that Rust assumes shared references to non-unsafe cell regions. What? What's undefined about this is that Rust assumes shared references to non-unsafe cell regions don't spuriously change. Okay. Um, so it gets So it gets to choose not to emit memory access instructions when it doesn't see any possibility for that memory to have changed. The only practical effects of this are that it's undefined whether foreign updates to the file will be observed or not. This may result in the program's view of memory becoming inconsistent and no longer containing correctly serialized data formats, but your deserialization layer is always responsible for dealing with invalid data. TLDR, memmap won't cause your program to miscompile, and trying to defend against it will destroy whatever advantages memmap might have given you, but you can always type the region as so-and-so if it makes you feel better. Atomics won't help you here, don't bother with them. Um, let's see somebody else's answer. In practice on Linux, the memory will change if another process modifies it. This leads to a lot of nastiness even if you ignore all the compiler level issues. If your memory mapped area is exposed as so-and-so, like in the popular memmap2 and memmap ix crates, actually, okay, that did not come up. Hold on, let's take a look at that. Memmap ix, a pure Rust cross-platform Rust API for memory mapped buffers. Give me a second. I'm just opening this up. Oh, that was a fork of memmap2. For some reason, it's taking time to load. What's going on? Like, what's okay? Fortunately, we are not dropping frames on screen or on stream, so we should be good there. And this memmap, well, memmap ix, this seems to have like more recent commits. It could just be one of those situations where the thing, the functionality has been built into it and there's no need for anything more to change. So they haven't changed anything in it. I should look into like which one I should be going with between memmap ix and memmap sync. And that is if I decide to go with memmap. I feel like we've gone way too off track with this. Okay, let's continue reading this since we are here anyways. Okay, memory mapped files in Rust. I'm new to Rust and I've been reading the book. Um, as a first project, I wanted to play around with some very large binary files, read them, iterate through them, etc. The first thing I did was look for a crate and I found memmap with over 7 million downloads. The first thought, was that this is great. Then I saw that it has not been updated in over 3 years. As I said, I'm new to Rust and I can imagine that a lot of things have changed over the last 3 years. Is this crate still relevant? Is there any better and non-abandoned crate? What problems can I expect in the future if I start a large project with this crate as a dependency? You might be interested in memmap2, which is a maintained fork of memmap. Okay. Oh, holy shit. Wait. Memmap2 was a fork of memmap, and then memmap ix is a fork of memmap2. That's crazy. Is that right? No, this is memmap rs that I was looking at. Um, this is, oh, memmap ix, I opened it elsewhere. Yeah, Yeah, memmap IX is a fork of memmap 2, but am I looking at memmap 2 here? I don't think I'm looking at memmap 2. Let me take a look at that. I'm looking at just memmap, which hasn't been updated in a while, but memmap 2 has actually been updated. In fact, it's more often updated um than it's more often updated than memmap. No, it's more often updated than memmap IX. These names are not easy to say. Um, has somebody, like, is there a link? I don't want to have to type the thing into. Actually, okay, I'll type it in here because I don't know what suggestions Google is going to throw up if I start typing, so I usually avoid it. Okay, Rust memmap 2. Okay, this is what I was looking for. So, yeah. So this is a fork of memmap, and then memmap IX seems to be a fork of, um, hold on, where's memmap IX gone? Oh yeah, memmap IX seems to be a fork of this. Though this is being updated. This is being maintained currently. Huge page support. Okay, file-backed memory maps, async, no, anonymous memory maps, synchronous and asynchronous flushing, copy on write memory maps, read-only memory maps, stack support. Okay, a list of supported tested targets can be found in actions. All right, great. So I guess the API would be the same as uh, as memmap. So like we can probably apply the same knowledge from here or the same workflow from here to memmap 2. All right, okay. All right. Why are memory mapped files unsafe? Okay, what does this person say? I came across a fork called memmap. Okay, okay, but it is unsafe here as well. Neither crates docs contain an explanation as to why it's unsafe. What does UB mean here? Let me Google this because this is the second time I'm coming across this. Oh, does UB mean undefined behavior? Rust UB. Oh, UB. Okay. UB is undefined behavior. All right. Um, okay, all file-backed memory map constructors are marked unsafe because of the potential for undefined behavior using the map underlying if the underlying file is subsequently modified in or out of process. Applications must consider the risk and take appropriate precautions when using file-backed maps. Solutions such as file permissions, locks, or process privates, etc. files exist but are platform specific and limited. Okay, all right. Rust can't check if anything else is using the file, right? Another process could edit or even delete it. In another thread, post it. I'm curious to try this out. Like, I want to see if the program just straight up panics or if it has some other way, some like undefined behavior If you modify a file, or even just straight up delete the file, and then you try to access this file that's been memory mapped, like what exactly is it reading at that point? Though I'd imagine what it's reading would really depend on, I think that would be OS specific, because that would depend on um, how the OS handles that newly freed space, what it's doing with that newly freed space. Okay, Rust rules are strict about references. mmap is much less strict and would allow the same memory to be obtained and multiple times in one or multiple processes. There is no mechanism provided by the OS to allow Rust to guarantee its behavior, so it's unsafe. Of course, unsafe Rust is still Rust, and if this is what you need, then go for it. That said, most programs don't need memmap. Okay, all right, all right. Yeah, we can get back to reading this. Is this what we were reading? No, no. Uh, we were reading this. Yeah, this is what we were reading. Um, Dude, I just realized something. I don't know how long this has not been captured. Oh God, this has not been captured at all. Oh my God. You guys have not been seeing any of this. This is what I've been reading. This was Gemini's response, but this was not being captured. That's crazy, dude. That's wild. That is crazy. Oh well, okay, whatever. So, where was I? I was okay. So, we were talking about like a massive file being read, and Gemini was explaining that, okay, this uses a technique called memory mapping. You tell the operating system to map the file on disk directly into your application's virtual address space. The OS doesn't actually load the 2 GB file into RAM. It just creates a pointer that pretends that the file is in memory. It's an illusion, but a very powerful one. You then point the FlatBuffers accessor right at the memory mapped pointer. The result is magical. Instantaneous loading. Your application can open the 2 GB file in nanoseconds because no data is actually being copied or parsed. Zero memory overhead. You can query the data structure as if it were in RAM, but your application's memory usage barely increases. Um, the OS will transparently page in the tiny chunks of the file from disk only when you access them. This makes FlatBuffers the undisputed champion for use cases involving random access into large static data sets. Think of a navigation map accessing map data. A navigation app accessing map data, a game engine pulling one specific 3D model from a giant resource file, or a mobile app looking up a single entry in a massive catalog bundled with the app. You get the performance of in-memory access with the storage capacity of disk. Is there really that much of a difference between the speed and size? Yes, the difference is very real and measurable, but it's not a simple case of one being better. It's about which phase of the data lifecycle you care about the most. Size difference, in depth. The general winner is protocol buffer. The why, as we discussed, the magic of binary formats comes from efficient encoding. Both 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 do this. However, FlatBuffers has a unique requirement to enable direct random access without parsing. It needs to store a roadmap inside the binary data itself. The roadmap consists of a vtable, which is a small table at the beginning of each object that stores the offsets to its fields. For example, it says the name field is at 12 bytes from here, the ID field is at 4 bytes from here, and so on. Pointers slash offsets. The data isn't necessarily stored contiguously. The main object may just contain pointers to where the actual data is stored later in the buffer. This metadata, the vtable and the pointers, adds a small amount of overhead. ProtoBuf doesn't need this because it processes the data sequentially. It discovers what's next as it parses. It's like a tightly packed scroll with no table of contents. A flat buffer is a book with a table of contents. The table itself takes up a few pages, but it lets you jump to any chapter instantly. When does it matter? For very small, simple objects, the flat buffer overhead can be noticeable. Example, a 10-byte protobuf might be a 24-byte flat buffer. For large objects with big strings or byte arrays, the overhead becomes an insignificant percentage of total size. You should almost never choose between them based on size alone. That's fair. Then speed difference, a detailed breakdown. Um, in serialization, in well, no, in yeah, okay, in serialization speed, the winner is protocol buffers, but in deserialization speed, the winner is flat buffers. I think flat buffers is a winner in deserialization because it can read like specific pieces from the data. It doesn't have to deserialize the entire blob. Whereas with protocol buffers, you kind of uh, have to parse the entire blob in order to have something that you can access. The why. The protocol buffer API is direct and simple. You instantiate a native object and set its properties like so-and-so. The library is highly optimized to take this final object and convert it into a byte array in one fast operation. The flat buffers API for writing is more complex. You use a builder object and must construct your data inside out. To create a person with name so-and-so, you must first add the string John to the buffer, get back its offset, and then create a person object telling you telling it to use that offset for the name. This indirection and multi-step process, I actually didn't know about this process. Anyways, this indirection and multi-step process can be measurably slower than the straightforward protobuf. Oh, you know what? Okay, I don't think it's me who has to do it. I think the API would kind of simplify this process for me, but like the program would still have to do it internally. I don't think I don't know. I'm not sure. Yeah, I'm not sure if I would have to do it manually or if this gets handled like behind the scenes. But either way, the thing has to be done, so that's one of the issues. Sorry, zoned out for a bit. Okay, where was I? Yeah, deserialization. Reading the data. The winner is FlatBuffers, and it's not even a contest. The why, this is the entire reason FlatBuffers exists. ProtoBuf. ProtoBuf performs a full parse. It allocates new memory for an object and then iterates through the entire byte array, interpreting the field tags and var ints to populate that new object. This takes CPU cycles and memory. It's very fast, microseconds, but it is a distinct non-zero step. Flat buffers, there is no parsing step. This is the zero copy principle. The raw byte array is the final data structure. The generated code simply lays a pointer and an accessor class over that memory. It's the equivalent of a C-style struct. The deserialization is effectively instantaneous. All right. Data access speed. Using the data after reading. The winner is protocol buffers. The why. After ProtoBuf pays its upfront parsing cost, you have a perfectly normal native object in memory. Accessing person.name is a direct pointer dereference, which is one of the fastest operations a CPU can do and is extremely friendly to modern CPU caches. When you access a field in a flat buffer, the generated code has to perform a few quick calculations using the vtable to get person.name. It essentially does this. Go to the start of the person object, look at its vtable to find the offset for name, add that offset to the object's start address to find the location of the string, and then this series of this series of indirections is still incredibly fast, but it's technically more work than direct access of the protobuf object. Conclusion on speed. If your bottleneck is the initial deserialization, example, you need to react to an incoming message in the absolute minimum amount of time. Oh, you know what? Okay, I get it. Yeah, I get that. Then flat buffers wins. If you are going to access every single field in the object multiple times, then protocol buffers can be faster overall because the one-time parsing cost is amortized and subsequent field accesses are more efficient. Sorry, zoned out. Okay, where was I? If you're going to access every single field in the object multiple, okay, I'm done reading that. I have to choose one to learn first. Which should I go with? Given that you don't have a specialized purpose yet and want to learn want to learn the one that will be most broadly useful, my strong recommendation is start with protocol buffers. Here's a detailed breakdown of why it's the better starting point. Vastly superior developer experience. The ProtoBuf API is more intuitive and feels like normal programming. The cognitive load is much lower. ProtoBuf, okay, so you create the object, then you can access or well, store values into fields. Great, awesome. It's simple, direct, and mutable. But with flat buffers, you have to create a builder. Then you have to create the offset. Dude, this offset thing is I didn't actually pay attention to this previously. Yeah, I didn't pay attention to this offset thing. I didn't know I would have to do that manually. That's interesting. Okay, this is more verbose, less intuitive, building inside out, and the resulting buffer is immutable. For a beginner, the ProtoBuf approach is much easier to grasp and use productively. And okay, the next thing, it solves more common problems. The vast majority of software engineering problems involving serialization are for data interchange between systems like microservices, web APIs, message queues, etc. In these scenarios, you typically send a complete piece of data, and the receiver needs to work with most or all of it. This is the exact problem ProtoBuf was designed for and excels at. The hyper specialized problem that FlatBuffers solves, like needing instant zero copy access to a small part. Dude, I feel like I would be able to use this um, on embedded devices. I feel like this would be a little, though I'm not entirely sure because you have to, like, if you're trying to avoid loading the thing into memory and you're trying to do a mem map kind of situation, the the embedded device has to be able to actually, do that, the mem map functionality. If you don't have mem map functionality, then you know, you can't really mem map then. And so then you can't access data from the file without fully loading the file into memory, and then you're back to square one. So I guess I need to also look into how memory allocation would work. Yeah, yeah. Yeah, the hyper specialized problem that FlatBuffer solves is far less common in general application development. All right. Then the third reason is the gateway to the gRPC ecosystem. This is a huge factor. gRPC is Google's modern high performance framework for remote procedure calls. I should look into this. And it is a dominant force in the world of microservices. Protocol buffers is the native default and required interface definition language for gRPC. By learning protobuf, you are simultaneously learning the foundational skill needed to build powerful, scalable, and language agnostic APIs with gRPC. This is an incredibly valuable and marketable skill. Um, while you can use flat buffers with gRPC, it's a less common community supported variant. Final analogy, learning protocol buffers is like learning to use a high quality chef's knife. Okay. Um, it's the most versatile, essential, and frequently used tool in the kitchen. You'll use it for 95% of your tasks. Learning flat buffers is like learning to use a mandolin slicer. Um, for the one specific task of making perfectly uniform paper thin slices at high speed, it is unequivocally un, un hold on unequivocally, holy shit, unequivocally, um, the best tool, but it's less versatile, more dangerous if you're not careful, as in a more complex API, and you simply won't need it as often. Hey Olax, hello, hello, welcome to the stream. How's it going? We are doing some research on protocol buffers and flat buffers. Yeah, it's funny because before starting today's stream, I was actually leaning more towards flat buffers, but then now I'm really leaning a lot more towards protocol buffers. And I think I'm gonna use protocol buffers a lot more until I actually have a reason to use flat buffers. Um, where was I? Yeah, start with the chef's knife, master it. Then, when you encounter the specific problem that needs the mandolin, you'll know exactly what it is and why you need it. Okay, great. Now, back to this thing. So we were reading, I believe this is in Java. Right, so this is our proto definition, and then this is the Java code. I actually okay, I should also check if there's well, no, there'll definitely be a Python version of this. Where's the menu? Yeah, let's look for the Python thing. Okay, Python generated code guide. This describes exactly what Python definitions the protocol buffer compiler generates. What? Hold on. What Python definitions? Oh, for any given protocol definition, any differences between Proto 2, Proto 3, and additions generated code are highlighted. Note that these differences are in the generated code as described in this document, not the base message classes slash interfaces, which are the same across all versions. You should read all three of these language guides before this document. No, no, dude, I'm not gonna. Hold on, how big is it? Okay. Yeah, no, we're not doing that. I'm gonna pick one and stick with that. Oh, you know what? I could ask the question to Gemini. Which conversation was I in? Should I open up a new conversation? Maybe I should open up a new conversation. Yeah, okay, let's cd into empty directory and start up Gemini here. What was this? And why does it look so broken? Oh, now it should be fine. Yeah. I think this was helping me understand. I don't think I need to look further into this anymore. So I'm considering using Rust to. Was this the Rust game dev web build thing? I mean, I'm still gonna do the game dev thing and still gonna focus on the web dev or the web build version of it. But I don't think I'm going to be like mixing up Nano and web dev. For web dev, I'm mainly going to be using Zola because there's quite a bit to learn with Zola alone. I don't want to like add unnecessary load because I was planning on learning Dioxys, but like, dude, if I keep adding stuff to my list, I'm never gonna go back to the data science stuff. And like, we need to get back to the data science stuff. Holy shit, there's so much that I have to study there. Data science and deep learning. I've put all of that on pause just so I can finish reading all of this. Which, I mean, to be fair, a bunch of it is helping because I am, in fact, going to be using Nano anyways. So I need to learn about Nano anyways. And any game dev stuff that I wanted to do, I was planning on achieving it through Nano. Any WASM research that I did, it was going to help to export the Nano built game or Nano built creative coding tool to WASM so it can be run in the browser. But yeah, I need to know where to, stop with that. Okay. I'm learning um I'm learning ProtoBuf, and it was mentioned somewhere to read the guides. Give me a second. Yeah, it was mentioned somewhere to read the guides for Proto 2, Proto 3, and editions. That's a lot to read. Um, can you tell me if there's something significant significantly different between them that I, as a beginner in ProtoBuf, need to be concerned about? Also, as a beginner, which specific one should I be focusing on? Because I was leaning more towards Proto 3 because I've seen um, support for Proto 3. I've seen Proto 3 mentioned in a couple of other places where ProtoBuf was being used. Um, yeah, yeah. Let's just wait for the response. Yeah. In the meantime, we can probably go through this list. Okay, compiler invocation. All right, it's done. Um, right. So, of course, it's a great question, and the documentation can definitely feel a lot, feel like a lot to take in at once. The short answer is, as a beginner, you should focus on Proto 3. It's the most common modern version, simpler to learn, and the concepts you learn there will directly apply when/if you move to editions. Key differences at a glance. Um, okay, deeper explanation and recommendation. So, Proto 2, the original, this was the standard for a long time. Its defining feature was the explicit required and optional keywords. The community eventually found that required fields were a major problem. If you needed to change a required field to optional, it could break old clients and servers. Verdict: avoid for new projects. You only need to learn it if you are working on a legacy system that already uses Proto 2. Okay, good to know. So that's one off the list. Then Proto 3, the modern standard. Google released Proto 3 to simplify ProtoBuf and fix the problems with Proto 2 like required. Its philosophy is simpler. Its philosophy is simpler is better. No more required fields, no more custom default values. This makes the generated code simpler in every language. Wait, no more custom default values? Oh, okay, all right. Everything is optional by default. This is the most widespread version in use today for modern applications. Most tutorials, examples, and libraries you find will be using Proto 3 syntax. Okay. Verdicts start here. This is the best place for a beginner to get a solid foundation in ProtoBuf. All right, additions. The future. After years of having two separate syntaxes, Proto 2 and Proto 3, Google introduced additions as a way to unify them and allow for smoother future evolution. Instead of a Proto 4, you now have a single addition syntax. With additions, you can opt in to specific features. For example, you can use a .proto file that generally follows Proto 3 conventions, but also but allows for explicit presence tracking like in Proto 2. Verdict, this is the direction ProtoBuf is heading, and you should use it for brand new projects started today. However, understanding Proto 3 first is the perfect prerequisite as the core concepts are identical. You can think of additions and Proto 3. You can think of additions as Proto 3 with more flexibility that you can learn as you need it. Final recommendation for a beginner, start with Proto 3, read its language guide. Its simplicity will let you grasp the core concepts of ProtoBuf quickly. All right. Focus on the core ideas, defining messages, data types, and use. I feel like so okay. I'm assuming right. I can ask this question. Hold on. Let's say I oh wait, what's going on here? Okay, yeah. Let's say I wanted you to teach me. I don't want you to just yet, but I'm just saying, um, is your model trained on both Proto 3 and additions? I'm assuming the answer would be yes, because Gemini is also a Google model. So like just by that association, I'm assuming that it was also trained on this. Yes, absolutely. My training data includes extensive information on both Proto 3 and additions, as well as the older Proto 2. This includes the official Google ProtoBuf documentation for all versions, countless open source code repositories containing .proto files that use these syntaxes, technical blogs, tutorials, and articles. Okay, all right. So when you are ready, I can explain the concepts of either version. I'm thinking I'll set up a prompt to make Gemini teach me ProtoBuf, and I'll tell it that, I mean, I'll have to pick a specific language. The thing is, I'm well versed in Python, right? I'm just slowly getting comfortable with Rust. So I'm wondering if I should go the Rust route in this case, just just so that I'm doing more Rust stuff. But the thing is, with with Python, I'm I'm going to be able to focus on learning protobuf, like learning the protobuf syntax, because I'm just that comfortable with Python, that I can quickly write up whatever logic I need. To be fair, I mean, I could do the same thing with Rust as well. It's not like that's going to be a major issue, because it's going to be very basic stuff. We're not going to be including any sort of networking thing, any sort of communication thing. We're going to stick with, and we're probably not even going to include. Um, oh well, I was about to say that we're probably not going to include memmap into this, but then memory mapping doesn't really come into it either, because that's a FlatBuffers thing. That's not a ProtoBuf thing. ProtoBuf is going to load up the entire thing anyways. But yeah, yeah, I should look into setting up that prompt, and then that'll be yet another new tutorial that I'm starting. I yesterday I was making this list of Gemini conversations that I'm yet to finish. Um, Fortunately, I can now remove flat buffers from that list, but I do need to then add the ProtoBuf tutorial thing to the list. I have to make that that prompt first because I'm going to do what I usually do. I'll tell Gemini to first generate a syllabus for me and then write that syllabus to a file in JSON form, and then we will go chapter by chapter. And for each chapter, I'll also ask it to give me an exercise at the end, and I will also explicitly tell it to not do any write operations aside from, writing the syllabus to a file initially. I'll tell it to not do any write operations. If anything needs to be done, tell me to do it so I can learn that way. Um, but yeah, other than that, I still have my LED multiplexing conversation that I have to read. Then there was the Lua. I actually, dude, I learned about Lua. Like I this time I actually went deeper into Lua. Um, it's going to be kind of complicated though with Lua because Lua is one of those things that I'm just not going to be using. I'm mainly learning it one for the sake of learning it, but also because NeoVim config files use it. So that's why I was learning it. I feel like I'm not going to remember a lot of the language features. Um, like, I don't know, a couple weeks or a couple months down the road, I'm not going to remember a lot of those language features. However, that's not going to be a complete loss because if the limited knowledge that I have in NeoVim, not NeoVim, in Lua, makes it so that when I look at a config file, I know exactly what I'm looking at, then I'll still count that as a win. It's not going to be a wasted effort. Then another conversation I was having, another tutorial, in fact. The Lua thing is also one tutorial I was going through. That's a Gemini generated tutorial. Another one is, or let's call it a Gemini generated course. Another course was the cargo workspaces course, because I wanted to learn about that whole, examples thing and how workspaces work, how you can have multiple projects within one workspace, stuff like that. Another one, which I don't remember if this was really a course or if it was just a series of questions that I'd asked, but in the past, back when I was doing stuff with Blender, I would always find myself being a little bit confused about, or not even confused, like I understood the concept of data blocks in Blender, and I understood up to the point where there has to be at least one user for a data block. If a data block doesn't have a user, then the moment you close Blender, that data block gets cleared from memory. So if you want something to persist, it has to have at least one user, even if it's a fake user. Okay, so that's data blocks. Then you had the concept of assets in Blender. You had assets, the asset browser, asset catalogs, and then they brought in brushes, which could also be saved as assets. They brought in like base models, which could also be saved as assets. But I didn't fully understand the concept of assets, or rather the inner workings of assets and all of their features and how you could share assets amongst different projects and stuff like that. I didn't fully understand that concept in order to be able to, use those features properly. So that's kind of what I wanted to learn, and that's a conversation that I'm also having with Gemini. And then there was another conversation about keyring functionality, which was kind of interesting because that was actually something that I didn't know was a thing in OSs. Um, Linux, Microsoft, and Mac OS all they all have their own implementation of the keyring functionality, or not even a key. I forgot what it's called, but it's sort of a it's sort of like a password vault kind of thing, where you can programmatically you can interact with this system that is running. Um, what was I saying? Yeah, you can programmatically interact with this system that's running to give it a key and give it a value or a password that's associated with that key. And it's going to be stored in a very specific way. And then you can also retrieve it later, but there's security mechanisms in place to sort of prevent malicious reading of that. Um, I wanted to understand that whole system as well, because I wanted a better way of storing OAuth tokens, um, and any other, like, credentials or something. I didn't want to be storing them in plain text files. So any sort of API tokens, or in general OAuth tokens that I would have, I want to store it into some location where it doesn't matter if it gets lost, but at the very least it shouldn't be exposed in like a file. Because if I'm going through, like, hold on, if let's say I'm here, right, and then I open up Yahtzee, there's a bunch of stuff here. I have to be careful while even scrolling through any of these, because I don't know what might show up. Maybe something that I'm not comfortable with showing might accidentally show up. So I need to be careful when showing any of this. And that includes even API tokens. There are actually situations like that. I believe for Kaggle, for the Kaggle API, or I forgot what it's called, Kaggle CLI maybe. Like I think there was, yeah, there's a Kaggle CLI tool, which which you can use to interact with Kaggle in various ways to download data sets, or models, or even download, or maybe just push. I don't remember. You can definitely push. I don't remember if you can download as well. But yeah, you can push notebooks on there, even run the notebooks on there. It's really useful. I was the whole reason I was looking into that was because I was gonna set up my terminal based workflow for working on Kaggle, because I can still use Kaggle's own compute resources, but in a slightly different way than the notebook based approach. Okay, right. Now, hold on for a second here. Okay. Uh, right. You know what? Um, we are gonna. Okay, so we are gonna go to this person's stream who we've rated them before. Their name is Will is Working. They're currently on their second channel where they are doing some studies. I forgot exactly what they're studying. I think it's something to do with genetics. But yeah, we're gonna go hang out there. They also have this really cool system that they designed entirely. Like this is really cool. They designed the entire system in Excel. They used the very limited tools that, because Excel gives you various tools for different types of automations and formulas and calculations and stuff. They used all of those tools to design an entire system that can generate different types of sentences based on different conditions and stuff, and it can then the end goal of that, I believe, is describing some kind of recipe for drinks. But yeah, it's a really cool system that they what's cool about it is not the system itself. What's cool is that they implemented that entire thing in Excel, in an Excel worksheet, because they don't know Python. They had been interested in Python, but they don't know it. After I saw that, my mind was blown. Like once they showed me the entire, like once they explained the entire thing to me, I was like, holy shit. But yeah, okay. That's going to be it for today's stream. Icarus, thanks for hanging out. Olax, thanks for hanging out. Anyone else who might have been lurking in the stream, thanks for hanging out. That's going to be it for today's stream. Once again, I'm really happy with the streak that we have going so far. I'm streaming a lot more regularly, and I'm happy about that. I'm pretty happy about that. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.